Almighty Father, we thank you for the gift of life you have provided to us. We thank you for this day. We thank you for this time that we shall be having our biology lesson, oh God. Come and be amongst us. Come and lead us from the beginning to the end. Direct our teacher. Make our mind be good to what our teacher will be teaching. Oh God, I pray all this believing you have heard in Jesus Christ our Lord. I pray. Amen.
Amen. Thank you very much, Rachel, for that beautiful prayer.
Welcome.
Okay. Now, not to waste time, as usual, my name is Bumba Patrick, and I've been the one taking you through our biology lesson. And it should be noted that I think this is the last lesson we are having in this program, whereby I think you are aware that we are soon doing exams, I think next week. Last week, we did something to do with the brain, and we did it in detail. But today's lesson, we are going to focus so much on the eye. We are going to focus so much on the eye. But as usual, I always first preview a little bit of the last lesson. So last week we did the central nervous system, and I gave you a brief introduction of how people started studying about the brain, which included several scientists. Then we learned about the different parts of the brain, whereby the brain is made up of the forebrain, midbrain, hindbrain. We looked at the different parts of the brain in detail and what each part does. We're able to know that our brain is divided into the left and right hemispheres. And I remember I talked of the different lobes in the brain, the thalamus, the hypothalamus, and what they do, and the spinal cord. And I think we ended with this question. But for today, I want us to look at the human eye. Being the fact that we are all humans, so I think we have this. Probably this picture may be a little bit abstract to some of you, because it is in what I can call a side view, but in 3 dimensions. Okay, this is the side view of the eye, but in 3 dimensions. So we are going to study about the eye in detail today. And if you are looking at this picture, these are the eyelids. These small hairs which are on your eye. They're called eyelashes, I think. Of course, some women and ladies, they are not comfortable having these hairs short, so they go to salons and they make them so long and I think curved. And I think you've seen women who have those long eyelashes. I don't know for what reason they do it, but they tend to do that. Now that means light must come from this side to enter through the pupil of the eye. The pupil is normally that black thing, that black thing in the middle of your eye. And I don't know whether you've ever taken note. Sometimes it can be bigger, sometimes it can be smaller, depending on the amount of light in the room where you are, or a situation that you are involved in. For example, when you are frightened, when someone scares you, it may become bigger. When you are calm and relaxed, it may become smaller. Then you could be having this other part on the side, which for some people may be brown, for some people it may be green, for some people it may be blue, for some people it may be gray, depending on your race or even your genes. Okay, and then so normally this part, as we are going to see, is the iris. Okay, and this dark is the pupil. Now on the side of the iris, you have this white part. Of course, for some people it is white, purely white. For some people it is kind of yellowish, and some people it may be even so red. Especially those who use drugs, this part may be a little bit red. Okay, and these are the eyelashes that I've talked of that women like expanding. I don't know for what reason. And then you are seeing in this corner of the eye, this little bit of membrane. Now, in humans, we actually used to have this membrane would stretch across stretch across the eye to clean it up, or even to evolution, we lost it. But in rats, you can find it still. Rats, emese. In Uganda, rats are called emese. They have this, we call it a nictitating membrane, which can stretch over and cover the eye, apart from the eyelids. So that is the outer part of the eye in just a summary. But when we are learning about the structure of the eye, normally, and I want to repeat, when we are learning about the structure of the eye, normally we look at this 2D picture, the 2-dimension picture, which is drawn using pencil or pen. And it normally disturbs very many students from understanding what actually it is. So for you to be able to see this, then the eye must be plucked out, and then you cut through up, down. So imagine the eye moves out and then you cut up, down, okay? And of course, our eyes can be able to move out if you didn't know. There are some interesting features which I want to tell you about the eye. For example, if you try to sneeze, I don't know whether you know the meaning of the word to sneeze. In Uganda, to sneeze means okwasimula, or like the president when he was addressing us during COVID period, he would use a term which he called okwetiamula. Okwetiamula, that is to sneeze. When you do that, when you do such a thing. Now, when you do such a thing and you don't close your eyes can pop out. When you sneeze and you don't close your eyelids, that pressure that is generated in the nasopharynx would push the eyes out and they would fall out. So you just have to be cautious that whenever you sneeze, you close your eyelids. Now, another interesting thing which I want us to take note of is look at these different parts. From the eyelashes, the eyelids, then you have a very thin transparent membrane, which is called the conjunctiva. Now here, when you look at this eye, you can't see actually the conjunctiva because it is that transparent kind of membrane. Here it's like as if you can't see it, but it is there. That transparent thin outer layer. Sometimes it can get bacterial infection and your eyes turn red, which is called conjunctivitis. Now, from that layer, you go to another thin layer, which is the cornea, is still around here. You can't see because it is also transparent. Now, from the cornea, there is a fluid here. It is a fluid before you can reach this iris, this gray layer, or some people it is green, some people it is blue. Mostly the whites tend to have blue or green iris. You get it? Now, before you reach that, there is a space, which is the anterior chamber, and you're going to find there the aqueous humor. It's a fluid called aqueous humor. Then from when you reach this gray or green or the which we call the iris, then that's where the lens is. The lens is inside your eye. From the lens, when you enter now, you go to this posterior chamber. Posterior means behind, anterior means towards the head or towards the front. Posterior towards behind, you get it, or towards the tail. Now, this is where you have the vitreous humor. It's some kind of gelic liquid. Also, that kind of has certain nutrients as well as maintaining shape of the eye. That fluid. Now from there, you go to, there are 3 layers actually, if you can take note of. You have, let me begin with the outermost layer, the sclera. It is white in color. If you've seen, especially when someone is dying, when a person is dying, in some people, depending on the disease that is making you to die, their eyes may want to flip backward. And then as they are flipping, you can only see the white part, this continuation of the white part backward. That's the sclera. Now, from the white part, as you're entering, imagine piercing through that white part. As you enter, there is a layer which is called choroid. That choroid layer, normally, of course, it's just to prevent internal reflection within the eye. And then from there, you go to that special layer. I'm calling it special because this is the layer that enables you to see. You see that, hey, I'm looking at a black bag, I'm looking at a red cup, I'm looking at a green shirt. That's the retina. But the retina has some special point on it, the fovea. Now, this fovea is the one that has many cells that enable you to distinguish different colors. Do you think all animals are able to see like you see? That you're able to see that this is blue, this is green? No, not all animals have that capacity. Actually, some animals have more capacity to see than us, but others don't have that capacity to even see color. They just see shades of black and white, depending on the cells that they have on their retina. Now, on the sides of the fovea, this is where you find cells that enable you to see at night or in the dark. And these cells, of course, you can't see color. Now, there's some special points which I want us to see for today. I want us to examine that special point, which is called the blind spot. Today, I'm going to make sure that you guys are able to see your blind spots today. At least if you didn't know, each one of you have a blind spot. And at this point, which I'm calling the blind spot, I can assure you, you cannot see anything in case light fell on this blind spot. And I think I want to begin with that exercise of us investigating the blind spot. And how are we going to investigate the blind spot? Let me show you. Here, the blind spot, first of all, you may need a paper or a book. Now, this is what you'll do. You'll get, actually, you can even use your phone. You can even use your phone. So you're going to hold the book or your phone, actually, about 50 centimeters away. And then you will close the left eye. You may use your hand because you can't close it well, to close the left eye and concentrate on this cross. So when you close the left eye, you make sure that you look at this plus. But as you are looking at this plus, you are also in the side, you are able to actually see this dot as well. But don't look at the dot, only focus on the plus. Now you're going to begin moving. You slowly bring the phone closer to your face. And when the image falls on the blind spot, or the dot falls on the blind spot, it will seem to disappear. You see that it will kind of be disappearing. And there's a point when you reach and you can't see it. Okay, I think please try to do that in about 2 minutes, and then you give me feedback whether you have been able to see your blind spot. Okay, so sorry for that. I was still telling you. I wanted to first know which people have been able to see their blind spots. Has anyone been able to see their blind spot? So only Carol has been able to see their blind spot. What about the rest? I don't want to continue before ascertaining whether people have been able to see. Claire, have you seen it?
Yes, teacher.
Okay, that's good. Even Emma, have you seen your blind spot? Okay. Nazua Jamila, have you seen your blind spot?
Yes, teacher.
Okay, I think since most people have been able to see their blind spot, I'm also seeing here people have written messages, they have been able to see the blind spot. Ahurire, Asinit, Kasata, Murungi, Asinit, yeah. Player has seen it. So that shows that actually what we are doing is it's not fake, it's reality. It's reality. It's not fake, it's reality. Now let us go on to understand our eye. So the structure of the eye is very simple. From the outward, that is when that white layer that you can see is the sclera, and then the choroid, and then the retina, and then the blind spot. This is where the optic nerves combine or combine to leading to the brain to form the optic nerve fiber. Then you have the fovea. This is the point where you are able to see more detail and color. On the retina. Okay, and then you have this vitreous humor, which is that you have the lens, and then you have okay, let me mute these people who are unnecessarily. You have the lens, and then you have the iris, which can be blue, gray, brown, like that. Then you have the aqueous humor in front, the cornea, and then some other layer, which is the conjunctiva. Now, in between, the lens is in between what I call the ciliary body. The ciliary body. So this in between the fibers, or you can call them enigua, which are holding the lens. Now, when the ciliary body contracts, these migua, they slacken and they become loose, and then the lens becomes thick and short. When the ciliary body relaxes back, when it is relaxing back, it moves backward. So when the ciliary body is relaxing, it moves backward. It puts a tension onto these ligaments, pulling the lens apart, and the lens becomes straight, elongated, and thinner and thinner. So we are going to understand more about that. Then this is what I've been saying. This is the ciliary body. So when the ciliary body contracts, it moves forward. When it moves forward, it doesn't put tension on the ligaments, so they become loose. When the ciliary body that is contracting, let me label this contract. So, and then when it relaxes, it goes back. It goes back. So this is relax. And once it relaxes, you can see that it's going to be pulling the suspensory ligaments. And when it puts tension in the suspensory ligaments, it pulls the lens and becomes thin and long. Okay. Going forward, that's another picture. Then the sclera, which is the outer white-most part, the outermost layer, it maintains the shape of the eyeball and protects the inner layer of the eye. Then conjunctiva, I talked of the conjunctiva, which is normally on top here. You can't see it, but it's a very thin layer on top of the cornea. Okay, that conjunctiva. It is thin and transparent, covers the cornea, and is continuous with the skin over the eye. The choroid layer, that's after outermost to the choroid layer. I said that one is pigmented beneath the sclera and maintains numerous blood vessels which nourish the retina. It also has pigments which prevents unnecessary internal reflections, so that light is not reflected inside here. Then the ciliary muscle, it is the one, this ciliary muscle is the one which is the shape of the lens. Because a lens, if it wants to look at nearby object, it should be short and thick. If it wants to look at a distant object, it should be thin and long, so that it is able to trap light at greater angles that are coming from a far distant object. But then here you need light that is coming from a nearby object. So that's why it should be short and thick. And then we can look at the suspensory ligaments. These are the ligaments in between the ciliary body and the lens. They look like threads, and they hold the lens in position. And then the aqueous humor, which is in front of the lens, is a solution which maintains the shape. Of course, it contains behind. Of course, it also has a purpose in refracting light. Then behind this lens, this is the lens behind it. Okay, let me use that one. Please keep muted. Don't disorganize the class. So behind the lens is vitreous humor, which is jelly-like, meaning that it looks like menida, mucus, or visigo. It looks like visigo, Vaseline. So it's a jelly-like substance that fills the inner cavity of the eye. It is also transparent and maintains the shape of the eye. It reflects light onto the retina here. And then looking at the lens itself, this one here, it is a transparent it is transparent and it is held by suspensory ligaments. This one is the one which further reflects light onto the retina here. It's not supposed to reflect light onto this blind spot where you have the optic nerve fiber. And by the way, depending on the structure which you have seen, because sometimes they draw when the black spot or the optic nerve is up, sometimes down, it doesn't matter where they draw it. Then the iris, it is responsible for controlling the amount of light entering. This part here, which can be gray or green. Please don't unmute yourselves. I'll be forced to mute you when you can't unmute yourselves. So this iris is the one which controls the size of the opening, which is called pupil. Then Mulungi Davis is asking that, teacher, which part of the eye is affected by blindness? Now, Mulungi, depends on the type of blindness which you are going to get. But in case, for example, if you remove the lens, it means that light is not going to be refracted here on the retina. You're going to be blind. Or in some people, this lens may be, but I think I'll comment much about it when we are under eye defects. Jesse, you have a question? Jesse, your hand is up. Can you ask your question? Okay, I was still telling you that depends on the type of blindness that you get. In some old people, it is the lens which becomes blurred. Like it may continuously become clogged with particles, and so that light can no longer reach the side. Okay, so maybe you could rephrase your question so that we see how we can go about it. And then the retina is where the image is formed on the eye. Okay, and then going forward, the blind spot, I've already talked about it. This is a region where the nerve fibers leave the eye to enter the optic nerve fiber. And that is this part here. Here, this is where you're going to have the blind spot. Blind spot. At that point, you can't see anything. At the blind spot, okay?
Yes, teacher.
Oh, these people. Then the fovea. This is a small depression in the center of the retina. It produces the most accurate images. And I've already shown you the fovea. Already, it could be here. Some kind of a small depression here. It makes you see then eyes, and then eyelashes prevent dusty particles and others from entering. Okay. Eye. So basically, those are the different parts of the eye, and I hope you've been able to understand because before you can even learn its parts, you're supposed to be able to label every part that you see here because it is highly examinable. They can draw for you the eye and they tell you to label all the different parts of the eye. And I hope by now you can be able to label all the different parts of the eye. JHK is asking which blindness which blindness as this where one, okay, sometimes typing error maybe. This where one looks at you, but you may think he's looking in another place. But is that blindness or it is a eye defect? Okay. The one which is called Ndari. So that's not blindness. Blindness, that is total, when you can't see anything totally, or you see partially. But if you still can see, those are a few eye defects that someone may get, okay? And we shall comment about those eye defects when we reach, because at the end of this eye, when we're learning about the eye, we learn about eye defects, okay? That's where I will comment about that. Then going forward, how is the image formed on the eye? Okay. Now, by the way, you must know this thing very clearly. When you are looking at an object, actually, for example, if you are looking at this man, and I'm assuming this is the lens of your eye, the image which is formed onto the retina is inverted. I repeat, when you look at a person or you look at a bottle, I'm assuming this is the bottle, This is the bottle. The image which is formed is inverted. Have I drawn it well? The image which is formed onto the retina is inverted. That is according to the light rays. And if you want to see how light actually works, I want you to write words somewhere and then use a mirror, say that those words are reflected in a mirror. You're going to see that the words are inverted also. Rachel Amek, you have a question?
Teacher. Okay, so I have a question. Like, why is it like when you press your eyes, you can see like, if you are seeing like only one thing when you have not pressed your eyes, and you press your eyes, you can see that thing adding, like there are 2 of them, 3, like that.
Okay, thank you for that wonderful question. Now, Rachel's question is actually very crucial in understanding how the eye works. Let me take you back a little bit. Okay. Now, whatever you must be looking at. Okay. Yes. Now, when you're looking at, let's say, I'm assuming looking at this boy here. You're looking at this boy. You're looking at this boy. For you to be able to see this boy, it line here. Okay. Against the
So we are not getting you.
The eye sideways. I'm assuming you press this side. Fluids here. Yeah. And some may be falling. I'm assuming this is another. Okay, like that. Some may be falling. Now, whichever light rays are focused here, they form an image. And that's why you may see more, you may see images overlapping. Actually, that is the word. You may see images overlapping, like you are seeing double or triple like that because of changing the focal point where the image is formed onto the fovea. And then let me see this question here. Mulenji says that who's about short-sightedness when we have reached teacher, what is the function of hair found at the top of the eye towards the head? Those hairs in Uganda, they are called ebisige. If you're having, I'm assuming this is your head. That's your head. And this is your eye. Now you may have those eyelashes, and then you're having that. You're having that. Now those are the ones that he's talking about, which you find. Actually, some women, what they do is they totally cut them off. They get a pencil and they draw their own. They draw their own eyelashes using a pencil. on top. But of course, some actually, they are called eyebrows. Are they called eyebrows? I think they're called eyebrows. So those ones, what is their function? The function, who can try to guess the function of those eyebrows above? Probably some of you could be knowing the function, or probably they have helped you in one way or another. Guys, what do you think could be the function of the eyebrows? Nobody? Robert is saying that prevent water from reaching the eye. Okay, thank you for that. And then Priska says to trap dust. Kasata, Josephine, what do you say? Kasata, Wade, Josephine, what do you say? She has failed to unmute. Let me ask Moira. Moira, what do you say?
They chop dust and add on the beauty.
Okay, thank you very much, Moira. And yes, I've got you, Moira. What about what do you say?
They prevent foreign bodies from entering the eye.
Okay, thank you very much, Joy. Then Paul says that they beautify someone. Maria says to crop dust. Kiria says for beauty addition. Priska says to enhance beauty. Emma says to protect the eye against light. How, Emma? And then Kyle says to prevent foreign bodies from entering the eye. Okay, and then let me end with Rachel. Rachel?
Says just for decoration.
Okay, Rachel says for decoration. Now, what you must know is whatever structure that is on our bodies, in most cases, it was put there for a purpose because they tend to have different functions. But alternatively, you must know that there are some parts of our bodies. Over time, they have proved to have no use. And such parts, they tend to keep on reducing in size, they keep on reducing in size. And eventually, after some years, they will even disappear for good. That is if they no longer have a purpose in us, okay? Of course, when you look at them, they are just slightly above the eyelids. So when you talk of that, of them preventing dust or foreign particles from above the forehead, that can be very right, okay? Then Rema says that keeping airborne dust, lint, and other debris from reaching the delicate eye tissues. Okay, and then, yeah, so it has to be with preventing foreign particles from flowing down towards the eye. That is a reason or a function that you could think about. But of course, because nowadays the environment that we are living in, it's as if they almost have no function apart from maybe, as some of you have said, in terms of beauty. But of course, when we are looking at functions of different body parts, normally it's not to do with the beauty, it's about survival. That is according to the animal kingdom. But of course, it may be beauty if you're looking in terms of courtship behavior in some organisms. Okay, so going back, looking at this inverted image, which is normally formed, it is the brain which now interprets it as, and then it tells you that it is what? Upright. Actually, there is even a study which was conducted And it is saying that, excuse me, sir, my network was poor. I didn't get you when there's relaxation and contraction occur later. Now, I was still telling there's a study which was conducted to prove that actually there's a study which was conducted to prove that the image formed on the eye is inverted. So they got special glasses and they gave to people who were under study, and those glasses would form an inverted image. So when they did it, the image, when they put on the glasses means garubindi or spectacles. When those scientists, the people understood, put on those spectacles, which would invert the image. After like 1 week, the people who are putting on glasses, they started seeing the images when they are upright. You see that? Then when they put off the glasses, they started seeing when the image is inverted until the brain corrected it afterwards. So that's when they confirmed that actually the image formed on the retina is inverted, but it is the brain that interprets it as an image which is upright. And then accommodation of the eye. With accommodation, this is the ability of the eye to form clear images of far and near objects on the fovea of the retina. So we call it accommodation. And for you to better understand this word accommodation, remember that you should remember that this word accommodation, normally the person who works in a hotel tells you that we have accommodation, meaning that you who is coming from near and you who is coming from afar, you can all come and we house you here, okay, in our bedrooms or in our hotel rooms. So accommodate images of far, that is images that are coming from a bigger distance, and near objects onto the fovea of the retina. Because the images are formed onto the fovea of the retina. And for you to be able to see a far and near object, lens, okay? Adjustments are done. For example, when you are looking at a far object, when you're looking at an object which is far, you need this lens to be thin and long. Why do you need it thin and long? Such that this image, like that is coming from, let's say this tree, that is coming from a far distance, the light comes at greater angles, okay? The light is coming at greater angles. In straight line, of course, I've drawn it poorly. And you need this lens to become thick, thin, and short. How does it become thin and short? It is this lens that relaxes, sorry, the ciliary body relaxes and it pulls backward, relaxes and pulls backward, putting tension onto the suspensory ligaments that pulls the lens to become thin and long. And once you want to see a nearby object here, you need this lens to be thick and short. So this lens contracts inwards. When it contracts inwards, there's no force onto the suspensory ligaments, they become loose. And so the lens becomes thick and short. Okay, that is what you must understand. Then when you're looking at a nearby object, that's what I've just commented about. Now, what about when you want to look at an object in dark, when it is dark, or when dim means little light. all in bright light. You need this pupil to, which is small, that is in bright light, in dim light for that. Now, in bright light, looking at this, you're having circular muscles which contract as now the lens, sorry, the iris is made up of two types of muscles. Those muscles are the radial and the circular, and they are antagonistic, meaning that they work in opposite directions. So when the circular muscles contract, these ones, they become so thin, and they make these people to be so small. Okay, but at the same time, the radial muscles are relaxed, so you are able to see so that little light is able to enter the pupil since you are in bright light. Now, when you are in dim light or little light, the ciliary, the radial muscles, these ones contract, pulling the pupil to become larger. At the same time, the circular muscles are relaxed, and you're able to see so that a lot of light enters the pupil, and you're able to see clearly in dim light. And this is the another picture. Okay. This is another picture. You can see this eye when in dim light. The pupil, that dark part, is big, so that a lot of light can enter. Then here, this picture is when you are in dim, in bright light. In bright light, you don't need a lot of light entering, so it's called to be small. It is these ciliary muscles. This is what you see. When the circular ciliary muscles contract, this is what you see. Okay. Okay. So I hope that is very clear. Infinix says that teacher is the use of the pupil. The pupil just lets in air. Sorry, not air, light. It's just that lets in light to enter the eye. That is what we are calling a pupil. Okay. And then let me see this other question from Nalima says, Master, does the impulses from the eye also go through the central nervous system? They don't go through, but they go to. I want you to take note of impulses from the eye. They go to the central nervous system. The central nervous system is made up of the brain and spinal cord. So impulses from the eye, they go to the central nervous system, not through. Okay. And then that's when we can go to eye defects. But before we can go to eye defects, I wanted you to first answer this question. Can you be able to name the structures labeled A, B, C, D, E, F, and G? So we can label this very fast because we are left with less time. So which one is A? You raise your hand, speak very fast, and then another person goes on. So which one is part A? Yes, Hosea.
Cornea.
Cornea. Is it cornea? Are you
Yes.
sure? Do you guys agree with Hosea's answer? Makubuya Tom?
Conjunctiva.
Makubuya?
Conjunctiva.
The conjunctiva. Okay, thank you very much. Conjunctiva, even Priska says conjunctiva. Then what about B? Which one is B? You raise your hand. Yes, Moira. Moira, your volume is low. Please increase your volume. Which one is part B?
It's called lens.
Okay, thank you, Moira. It's a lens. Part B is lens. Then we can go to C. Which one is part C? You raise your hand very fast. Yes, Mulungi Davis.
It's the iris.
C is the iris. Thank you very much. And then part D. Which one is part D? Blessing. Yes, blessing.
Sensory ligaments.
Sensory ligaments. Thank you. That's very correct. Then which one is part E? Which one is part E? Yes, Makubuya.
Ciliary body.
Ciliary body. Thank you, Makubuya. What about part F? Part F. Which one is part F? What about the rest of you? I'm seeing a few people are putting up their hands. Which one is part F? Which one is part F? Yes, blessing.
The retina.
Part F is the retina. You can see that this arrow or label line is going deep up to that layer. Then G is in the middle layer. What is the name of that middle layer? Yes, Davis. Okay, let me choose another one. Promise. Yes, promise.
Teacher, it's the choroid.
The choroid layer. Thank you, promise. And then Carol. Carol, which one is H?
Sclera.
The sclera. The sclera. Thank you for that. And then here in the chat, Blessing had said ciliary body. Kauma is asking, are they in Google Classroom? The notes about the eye, no, they are not yet there. I'm going to upload them, but the one for the brain, they are there. So I'm going to, after this lesson, I'm going to load them. Then we are left with a few minutes. Okay, let me pick some few questions. Carol, you have a question? Carol, I'm seeing your hand up. Okay, let me animate. Yes, Carol, you have a question? Okay, I think Carol has no question. Now, in these last minutes, I think there's some information which needs to be passed on. And I don't know, Mr. Rogers, are you there? There's some information.
Yes. Yes, thank you very much.
Yes, I don't
teacher.
know. Okay, good. Yes. I don't know whether there's some information.
Thank you very much. I'm going to. Yes, let me share about this briefly. Are you hearing me or I'm breaking?
We are hearing you.
We're hearing you.
Okay, thank you. Yeah, so learners, like the teacher told us at the beginning of the lesson, this week is the last week for our normal lessons. And next week, we are going to be exams. One, like someone there has been asking about Google Classroom, we expect that you are on Google Classroom. There is this app called Google Classroom. So we expect that by now you have it and you are able to open. So for example, when I open This is senior 3 class. So under classwork, you'll be able to find the work that the teachers have been and prepare for exams next week. So the work is there, the notes for all subjects. So please you check your timetable. The timetable has the class code. If you are not yet there, you will go to Google Classroom and then you'll find a way of joining a new class. You use this button here at the bottom, and then you say join class, and you put in the class code. The class code is on the timetable. Once you put in that class code and then you say join, you'll be inside the class, and you'll be able to access all the work. Okay, so that is one. Then 2, what is going to happen after the exams? After the exams, we are going to have a revision of the exams. Then we shall be concluding with this program, the live lessons this October at the end of the month. So, but as teachers, we have been thinking that maybe we can continue sharing with you during November, December. We shall continue sharing with you some revision work, even when this lesson, the live lessons will be over. So we encourage you to go to YouTube. We are going to be putting some, we have a channel called the Christian. So you go to YouTube, you'll search for an app, it's known as YouTube. It is also on your phone. Yeah, so then you search for Christian School Owners Association. So on this website, on this, when you search for that, you'll see this channel. It's a YouTube channel here. So you can be able to find this channel. So what you do, you click on subscribe. There's a button here that you are going to see here. This red button here, you are going to see it there. So you will use it to this one here. So you'll use it to subscribe. And I want to encourage you to try to do that immediately after this particular lesson. You subscribe because we are going to be uploading some other self-study videos which are going to be prepared by the teachers, and we shall be sharing with you. So you subscribe to that channel so that we can be in touch with you. Then finally, we are having in this last week, the scripture union has joined us. Every morning they are having some lessons they are going to be teaching, and also some prayers. So we need to learn more and be able to appreciate more. Yeah, so every morning at 8, we use the link. There's a link that we have for senior 3. We are going to be using the link for senior 1, senior 2 e-classes. Yeah, the link for senior 1, senior 2 e-classes, that's the one we are going to be using every morning. We have shared that link, the link on the timetable for senior and senior 2 e-class that we are going to be joining for the scripture union lessons. Mr. Patrick, I don't know whether my communication was clear. That's what I wanted to say, to tell the learners.
Yeah, it has been very clear. Yeah.
Okay. Thank you very
much. Been very clear. You're welcome.
Actually, now, let me share with them actually the link in the chat. The direct link to the channel. They can just click on it and then they subscribe. Okay, it's fine. Yeah, you can go ahead. You can take on.
Okay. Finally, let me conclude. So I'm going to share this. You're going to see you'll find notes which have a small title called the brain. Okay, and in the eye, in Google Classroom, you'll be able to access these notes. I'm going to share them right after this lesson under the senior 3. So otherwise, if there's no any other question, bye-bye and enjoy yourselves. Have a lovely afternoon.
Thank you. Bye.
Thank you.
Bye.
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 Thank you.
Thank you, teacher.
Bye-bye, teacher.
Bye-bye, teacher.
Teacher Patrick, you can close the class.